Okay, so today I'm going to look at the series parallel. These two resistors are in series, but it's in parallel with the 1K and the 4K. So I'm going to add them here, and I'm going to put 5K. So now to minimize this circuit, it's just 1K in parallel with 4K in parallel with 5K. And remember, you should, and when in parallel, you'll get smaller than the smallest resistor should be your R total. In this case, it's 689.66 ohms. So then we're going to circle that. We're going to redraw the 25 volts. Here's the 500. We haven't done anything with that yet, but what we did is minimize all of this to make it 689.66 ohms. Okay, 689.66 ohms. So at this point, you get E total, R total, I total, right? And then you get these two voltage drops here and here, and they both have to add up to 25. So we take 25, so then we'll take E total of 500 plus 689.66 ohms, and we get 1.190K ohms because of the rounding, right? So then E total we know is 25 volts. So we can take 25 volts divided by R total to get I total. So here we can do 25 divided by shift answer, which is R total. And we get 21.01 milliamps. 21.01 milliamps. So we know that we have 2101 milliamps running in this circuit, right? So now we have to get their voltage drops. I'm going to save that current by saying save in alpha Z. So now I have it saved. Alpha Z times 500 gives me 10.51 volts. Then alpha Z times 689.66 to get that voltage of 14.49 volts. Okay, this voltage is going back to the 1K, the 4K, and the 5K. But this 5K is broken up to 2K and 3K. So the 14 volts will be divided by the 2K and the 3K. But all three of them should be 14.49. So we got 14.49 volts here. We got 14.49 volts here. And then we can say 14.49 volts divided by 5K, because we'll get the current there, which is 2.90 milliamps, right? That's the current for this 2K and the 3K. We can multiply that by each of our components, so we can save it in alpha Z again and do alpha Z times 2K to get the voltage there of 5.80 volts. And then we'll get the voltage for the 3K, 8.70 volts. That's 70 volts. These two must add up to the 14. To get the currents, we're just taking E divided by R to get I, E divided by R to get I. And that's it. We have voltage drops, we have current for these two. So the last step is to just take that 14.49. Matter of fact, let me just do it. 14.49 volts divided by 4K to get 3.62 milliamps here for that 4K. And 14.49 divided by 1K, we should get 14.49 millivolts, because it's here. 14.49 millivolts, 14.49 milliamps, sorry. And that's it. Thanks.